Hello and welcome to our last video on piecewise functions. We've talked about how to evaluate piecewise functions, how to graph piecewise functions, how to write a piecewise function when given the graph. Now we're going to put it all together as we talk about applying piecewise functions. So we're going to take a look at an application problem where we see a piecewise function that would be used in the real world. Between this video and your homework assignments, you can actually see that we use piecewise functions all the time. We use it when we sign up for, when we have a deal that's like from this number to this number, it costs $20 a person, but if you get 8 or more people, then it's only going to cost $15 a person. That's a piecewise function. We don't graph it. We don't always write an equation for it, but we're creating a piecewise function to help us understand what's happening. So let's take a look at this question here as we talk about piecewise functions. So it says you rent a karaoke machine for 5 days. The rental company charges you $50 for the first day and then $25 for each day after that. Write and graph a step function that represents the relationship between the number X of days and the total cost Y in dollars of renting this karaoke machine. Now, before we look at that problem, I want to talk about what a step function is. So a step function is a type of piecewise function, but instead of it being like piecewise functions where we have a part that goes to here and then another part that does this, and there are these angled sloped lines, a step function has to be straight lines. So if we were to see a step function, we might see something that looks like this. Do you see how it looks like each consecutive piece is a step? That's exactly what we're looking for. So it goes from point A to B, and then B to C, and then C to D, and then D to E. And each time it's just a straight line. So it's not going to equal a sloped line, like this one might be X minus 1. These are going to be solid numbers. So this would be the case when like Y equals -2. That would be like this one right here. So in our function, we might see something like f of x equals 2 if x is between -3 and -1, right? Or -3 and -2. And then it might equal a -1 if x is between -2 and -1, right? And so then it's just that function stepping up, stepping up, stepping up. And that's just what it looks like. So each of these are not going to be those expressions in slope-intercept form. These are just going to be an integer that tells us y is equal to -2, y is equal to 3, etc. So we're going to write a step function for this problem. So we're renting a karaoke machine. We got 5 days. So we know that we're going to have a step function because it's got multiple days there that we're dealing with. So f of x equals, and we've got our big curly bracket here, 5 days. So how much money does it cost on the first day? Well, it costs $50. So I know on day 1, it's going to be $50. So we are looking at that from the moment that you rent it on day 1 all the way until day 2, but not including day 2. So it's from when we get it on day 1 all the way up until day 2, it's going to cost $50. Then each additional day is $25 after that. So at the start of day 2, how much money are they going to charge us? 50 plus 25, which is 75. And that's going to be all the way up until day 3. And then day 3 comes around, and we are looking at $100 total. Day 4 comes around, we're looking at 125. And then day 5 comes around, and we're looking at 150. Now notice this goes all the way up to day 6, but it doesn't include it. Because remember, we have it for the full day 5, but we don't have it for day 6. So now let's look at what our step function would look like. Now, we've got our x values here. Remember, these are the days. And then over here, we have the cost. And this is in dollars. So let's look at it. I'm going to go up by 50s. So we've got 50, 100, 150, 200. Okay, so from day 1 to day 2, including day 1, open circle on day 2, it's going to cost me $50. So from day 1 to day 2, it's going to be $50. But as soon as day 2 hits, we go up to $75 here. And then that'll go all the way to day 3. And then as soon as day 3 hits, we go up to $100. As soon as day 4 hits, we go up to $125. And as soon as day 5 hits, we go up to $150. Okay, this last one's an open dot here. So that would be how we would graph that piecewise function. It's a step function because they're all the same there. They're straight lines, as you notice, but that's how cost works. We're not in a parking garage where it changes every hour. They just say, if it's this day, it's going to cost you $25 every day after that. So it's going to be consistent. Now, there are other times when we use it. An example might be if you're renting equipment, or if you decide to go into some sort of optics, you might end up seeing that here we have an example of a time where they're using holography and they're shining a laser and shooting it off of a mirror, then go off of the film plate, and then it shoots off another mirror, and we create a 3D object based on these reflections. Super cool. Now, you are using these piecewise functions here for a problem like that because you have it going up to here and then it bounces off. So you've got from negative infinity, or in this case from 0 to 5, and then from 5 on, right? So that's kind of what we're looking at there. It's also interesting because you can write absolute value functions and piecewise functions from the same graph. So make sure you look at what's being specified. But piecewise functions are super cool because we can apply them to so many things in our lives, and we use them all the time, even if we aren't writing the equation, graphing it, or evaluating it. We really are evaluating a function when we try to decide these things, like how much it's going to cost to rent a karaoke machine. So if you have questions on piecewise functions, feel free to watch the previous videos that discussed what a piecewise function is, how we evaluate it, how we graph it, and how we write them. Thanks.